Alright, for the last few months, I've been tracking updates about Comet 3i Atlas, as has everybody else, unless you've been living under a vacuum, in a vacuum, whatever you've been doing. I've got three things to raise, 3 points. Number one, I've looked at the publications on the comet and have analysed the data about the luminosity and colour of Comet 3i Atlas. Number two, I've noticed that music in the form of urban and contemporary rap music genres can be extracted from the dataset I was looking at. Number three, I started to write this music down using modern studio software, and well, here we are. Yeah. Now, for the other part, I do two parts. Prime numbers, then Fibonacci. Yeah, prime numbers, I went through that yesterday, the previous video to this one. And basically, for the ages of man, I went through it with a prime filter. Now I'm going through it with a Fibonacci filter. And so what you're going to have is the same thing as primes, but now you have the Fibonacci numbers. The top row is for the ages, the ages of man, 1, 2, 3, 4, 5, 6, all that. The second column is the note numbers, and this one went up to let me see, went up to 55 because the next one is 89. So, and those are the subsequent notes for it. I've got here primes, but it should be saying Fibonacci in it. Right. Right, okay. So that's how it looks like. And I always play you the raw version, just the notes. Tell me what you think. Right. So that is the tune when it's raw. Now, I also actually took that tune and I made a proper one now. So what I noticed, everything goes off all right when you're note to 13, but after 13 things just become pear-shaped. So that's when you become proper bashment, when you're 13. So before I play you my song with this in the background, I'll go through what kind of like gets me about this topic, Fibonacci. The first question I had to ask myself was basically, it's a consideration. I'm not necessarily touching on the creator, but based on what I'm seeing, what I estimate things are to be, that's what I'm going by on this. I'm thinking to myself, like, you have a coin, it can be heads or tails, right? But every coin needs to have two sides. Well, there's really three sides. There's heads, tails, but what's gluing it together? The edge side, because there's been coins which have been tossed and then it lands like on the curb, on the skirting or whatever they call it, and it lands on the edge side. So there's actually three sides to a coin, but let's not go into that. Let's say two. That's the normal belief that we have. So where you have destruction, that's part of the same coin, as construction, right? A destructive force yeah, is one side of a coin that includes a constructive one. So wherever you see destructive forces, there's constructive forces. Yeah. So what you have earthquakes. If you followed earthquakes and tectonics, you know that there's earthquakes in the sea, yeah, that crack the crust open and form new islands. Yeah. And then there's subduction, where there's earthquakes that happen that swallow up old continents and old islands. So the force of the earthquake creates new islands, new habitable zones for human beings to live in. Yeah, so when a human being sees that happening, thinks, okay, earthquakes are a good thing. Yeah, but on the other side of town, they're destroying cities and where people have been. Yeah, so to those people, earthquakes are a destructive thing. One man's meat is another man's poison. So what I ended up asking, yeah, just to get a rough idea of what this is, and link it to Fibonacci, yeah, is, you know what? Let me play my new tune. I think I'll go through this when I'm playing tune. Yeah. All right. Run it. Volume, level. Same tune. Remember the notes. All right. Let me go through what I was telling you, yeah? Right. So you ask yourself, yeah, what is the average density of the human body? Yeah, I calculated it. Took me some time, but you got to believe me on this. Yeah, let me show you how. Yeah. First of all, what I did, yeah, I really went to town on this. Yeah, so here, listen up. Yeah. So let me go back to the beginning. Yeah, let's see. Yeah. So human body is around 0.985. What's that? Yeah. G grams per centimeter cube. Yeah. That's around the same density as water, which is 1,000 kilograms per meter cube, yeah, which is one, yeah. That's how I studied it anyway. So that's the average density of the human body, yeah. So then I went to the next question. It's like, what's the closest compound or element to our density out there, yeah? And again, I was just using AI overview. Like, I didn't really want to go into the math because, like, I'm not really on that. There's people with the hat on that can give you a more clearer or more intricate explanation, but I'm just like hovering over that. Yeah. So now I'm saying to myself, yeah, there's plastic additive, yeah, that has a recorded density of exactly 0.985, like how the human body has, yeah, 0.985 cc, whatever they call it, yeah. So plastic additives have that, yeah, right? And I'm looking at that plastic additive that I just showed you on the screen there, yeah. It's called dioptyl phthalate. Dioptyl phthalate. I need to bit my lip saying that, you know. Dangerous occupation pronouncing Latin words, you know. Especially when these lot are put them together. Yeah. So anyway, DOP for short. You can see why. Yeah. So that one there is what's it called? A large organic molecule, right? It doesn't have a single molecular frequency, but it has a spectrum. They measure the spectrums, so they give you wavelengths. I'm sitting in there typing in what's the frequency of this one, and it's giving me wavelength. So I recognize wavelength. Yeah. It gave me let's use 1724. Yeah. Yeah. Let me see if I can highlight it so you can see. Yeah. Anyway, that one there, carbonyl. Yeah. Right. So then I asked it, what is the frequency, yeah, of 1724? Yeah, 1724 right there. What is the frequency of that? Yeah. They're saying it's 5.168 times 10 to the minus times 10 to the 13 hertz. So I'm thinking, is that visible? Well, it's not. Yeah. So I'm saying to myself, yeah,
what are the frequency ranges in the electromagnetic spectrum? Yeah. So you look at if you look at all the way down to infrared. Infrared is in the order of 10 to the 13, right? Same order as this one, right? Oh, yeah, 10 to the 13, around there. So that molecule, DOP, same with our flesh on average, gives off that frequency, but we can't see it because it's infrared. So all we see is heat when it's given off. Yeah. So just imagine if light wasn't reflected on our bodies. Yeah. We still release electromagnetism, but it's heat. It's invisible to this. You need to wear goggles, infrared goggles, to see it. So what does a human being look like when light can't bounce off it? Let's say you ate something, a dodgy tablet or vitamin, and your skin stopped reflecting light. Yeah, you will look like a ghost, like a shadowy figure, innit? Because there will be no light bouncing off you. So what color would you be? You'd be pitch black, or you look like a wavy line of heat. There's some people who can see like heat coming off hot things, like, you know, but a naked flame, you can see the flamey bit, but just beyond it, you can see wavy lines of heat. That's what it would look like if light can't bounce off your body, you know? Yeah, so that's a question I ended up asking myself, and I thought, all right, so to explain Fibonacci, yeah, you have to think that every Fibonacci frequency number repeats itself, yeah, right? So if we go back to my table quickly, yeah, show you all the Fibonacci numbers, yeah. Hold on. Yeah, right, there's Fibonacci numbers, right? If you take, for example, 144, every 144 years, yeah, is a Fibonacci duration, right? So if you take 987 is a Fibonacci number, yeah? If you multiply that by 2, what do you get? Yeah? Let me think. 1974, I think. Yeah. Or is it 1976? 1976, I think. Yeah. No, 1974. Right? Yeah, 1974. And that's it. That's a date that you remember, isn't it? So 1974, there was a Fibonacci repeat, right? a repeat of 987, which is a Fibonacci number, right? So you bear that in mind. Yeah, these numbers repeat. So my shit was gonna get funny from there, but I caught it just now. Yeah. So during those moments when it's repeating Fibonacci number, there'll be something significant happening. Yeah, I don't need to explain to you what all the spirals of the galaxy look like. They look like the Fibonacci, in that you can actually deduce Fibonacci sequences and the way they spiral, I think. Yeah, and even petals on flowers and shit go 5, 8, 3. You've never seen a 4-leaf clover yet, but you can see 3. Yeah. Or is it 5 clovers? I don't know. Yeah, so anyway, so yeah, that's how it goes. Yeah, that's how it goes with a Fibonacci. Yeah, you got to think to yourself that I won't be revealing too much because I'm freestyling on this. Yeah, but I say that, you know what? Yeah, energy can never be created. It either turns into mass or some other form of energy. Yeah, but if you think about it, yeah. Put it back. Yeah. So. Yeah. What if consciousness is also related to energy then is related to mass? So if energy equals mc squared, then consciousness must equal energy times the speed of consciousness squared if you go backwards by 1. Nah, that's no, I won't. No, it's done. Yeah, just enjoy listening to the song. It's done.